You know, just think about it for a second. With a simple flick of a switch, you and I are tapping into one of the most complex machines ever built. I'm talking about the energy grid. It's this absolutely massive, sprawling network that powers our entire modern world. But it's facing some pretty big challenges. It really is like an invisible giant, right? It's this hidden infrastructure of wires and towers that we just don't even notice most of the time, but we depend on it for literally everything. The scale is just staggering, and our whole society is built on the assumption that it's just going to work perfectly all the time. And that brings up a really interesting question. I mean, in a world that is completely driven by data and real-time information, how on earth do you manage something this huge and this important? How do you actually keep the lights on efficiently and safely? Well, to answer that, we've got to first understand the network's hidden challenge. And it's not really about the physical hardware, it's all about the information. See, for way too long, trying to manage the grid has been like trying to solve a massive puzzle with all the pieces scattered across the floor. You can't just optimize one little part in isolation because it's all connected. It just doesn't work. You absolutely have to see the full picture, the entire network all at once. And this right here, this is the core of the problem. Historically, all the data you'd need for that big picture has been totally fragmented. It's stuck in different departments, sometimes on old paper maps or in clunky, outdated spreadsheets. This makes it pretty much impossible to get a complete, real-time snapshot of what's actually happening out there on the network. And that really highlights the huge shift that needs to happen. We've got to move away from this world of siloed data and just reacting to problems. The modern grid, it demands a unified, real-time view that lets you plan ahead and gives you total situational awareness. So, what's the solution to this gigantic data mess? Well, you can think of it like this. It's about giving the entire grid a centralized digital brain. And that brain has a name. It's called a Network Information System, or NIS. Just think of it as the single source of truth for every single thing on the grid. It's a central, web-based platform that helps manage the entire life cycle of every asset in that network. And we're talking about a pretty broad scope here. A modern NIS isn't just tracking the main power grid. Nope. It integrates everything, from the power lines to the streetlights on your block, and even district heating systems. All of it, in one unified place. Okay, so that sounds great in theory, but how does a system like this actually work in the real world? Let's take a look at how it all comes together. Really, it all comes down to managing that full network lifecycle, from start to finish. It kicks off with planning and analysis. From there, it moves into digitally managing the whole construction process. Then, it handles all the crucial day-to-day operations and maintenance. And finally, it closes that loop with reporting and even simulating future scenarios. It's a complete end-to-end workflow, all inside one system. And the tools that make this happen are incredibly powerful. I mean, imagine having a full asset register where every single component has precise geographical information tied to it. Now add in tools for complex network analysis and the ability to simulate what-if scenarios, like what happens if a major storm hits, or if there's a sudden huge spike in energy demand. This quote right here really gets to the heart of what makes this so revolutionary. Data created in digital form immediately, we're found. That's the game changer. No more clipboards, no more waiting for someone to type data in back at the office. Information is captured digitally, right at the source in real time. And this is how it actually happens. You've got web and mobile apps that, by the way, even work when you're offline, so a technician out in the field repairing a line and a planner back in the head office are looking at the exact same up-to-the-minute data. That gap between the field and the office, it just completely disappears. So yeah, the technology is really impressive, but what does it all really mean? What's the actual real-world impact of giving the grid this kind of digital brain? Well, the benefits are huge, and they pretty much fall into three key areas. First, operational efficiency just skyrockets thanks to digital processes and automation. Second, it's way more cost-efficient. Because these are modern cloud-based systems, you don't need a massive upfront investment in hardware. And finally, customer satisfaction goes way up. With better awareness, utilities can restore power faster and keep everybody in the loop. What's really cool is that this model is also built for how businesses actually work today. You know, utilities often rely on lots of external contractors. A cloud-based system like this lets everyone, internal staff, partners, contractors, collaborate on the exact same platform, seamlessly, and you don't have the headache of user limits or costs that keep climbing. But this isn't just about making today's grid run a little better. This is really about building the network of tomorrow. And these systems, they're not built in a vacuum. They're built on a foundation of proven, powerful technologies, using industry-standard geographic information systems and integrating smoothly with other critical management software. This whole ecosystem of strong partnerships is what makes the solutions so robust, reliable, and ready for the future. Ultimately, the goal here is to create a grid that's not only efficient today, but is also sustainable and totally prepared for the challenges of tomorrow. Things like integrating renewable energy or handling all the new demand from electric vehicles. Which kind of leaves us with one final thought. We know our energy future is becoming more complex and more digital every single day. The real question we have to ask is the brain of our most critical infrastructure actually ready for that future?